Hi, everybody. I'm a gummy bear. I sure wish I had some friends around. Hello. I'm Green Gummy Bear. You're green? I'm red. We're going to be best friends. And it's time for our favorite school subject, math.
Hey guys, hey gummies, how are ya?
Oh, it's Mr. Quick. Are you here to do math with us?
No, not math.
Not math. Science?
No, not science.
Social studies? I love social studies.
Not social studies.
Oh, English language arts! Yay!
No, sorry guys. Not any of those.
Then what is it?
Well, we're gonna do lunch.
Lunch? No! No!
That was good. Let's do some math. Okay, let's jump right into it. Today we're going to talk about a lot of things, and I'm going to move pretty quickly because they're all fairly easy concepts once you have some practice time in, and we're going to get that practice time in during class. So this will just be kind of a quick review or quick introduction. Okay, we're going to talk about factors, prime and composite numbers, prime factorization, and greatest common factor. Some of that you may have heard of before. Prime numbers are divisible by only one and the number itself. So 11 is a prime number. If I was going to write down all the numbers that can be divided by, or that 11 can be divided by, 11 divided by 11 is 1, so those two would go together, but there's no other numbers. You know, if I divided 11 by 2, I'd get 6.5. Okay, so you have to be able to divide the number and still get a whole number. Okay, 7, also a prime number. 7 divided by 7 is 1, but 7 divided by 2 is 3.5. Okay, 7 divided by 3 doesn't work, 7 divided by 4, divided by 5, divided by 6, none of them work. None of them give you a whole number. So those are just two examples of prime numbers. Composite numbers, however, are divisible by more than two numbers. 6 is a composite number. So if I write 6, well, 6 can be divided by 1 and 6, but 6 can also be divided by 3 and 2. Okay, so you see that there's more than two numbers, so it's a composite number. Another example, 10 is a composite number. 10 and 1, but also, what else can be multiplied together to equal 10 are divisible? 2 and 5. So when you have more than two numbers that are divisible, you have a composite number. 0 and 1 are not prime numbers. 0 and 1 are not composite numbers. They're neither, and we'll talk about why in class. But it's just important to remember that they are neither prime nor composite. Numbers that can be multiplied to find a product are factors of that product. Okay, so again, we just did the factors of 10 basically. I called it divisibility, but it's the factors. Okay, 1 times 10, 5 times 2. Those are the factors of 10. So the factors of 10, if I was going to write them down, I'd write 1, 2, 5, and 10. Those are all numbers that can be multiplied to equal 10. And here's how I do it. Okay, I always write the number, and I always start with 1. Because you know that the number, any number times 1 is itself, you know 1 and 10 are going to be on that list. Then I go to 2. Can 2 be multiplied by anything to equal 10? Oh, yes, it can. Okay, 2 times 5. So I'm going to write those two. 3 is 3 times 2 times 3 times 4 times 5. Is 3 times anything going to give you 10? No, it's not. What about 4? Nope. Doesn't work. So you notice I'm not writing those down. What about 5? Well, 5 is already on there, and once you come to a number twice, since we've already written 5 down, 2 times 5, now we're just looking at 5 times 2. It's the same thing. We're done. So that's the whole list. Those are the factors of 10. Prime factorization of a number is the number written as the product of its prime factors. So, for example, I'm going to go back a page. These are all factors of 10. but these are not all prime numbers. So let's look, just for an example, at 36. And this is an example that's in our books. I'm going to write the number 36. This is a factored tree. You could pick any of the factors to start with. Let's say 3 and 12. Okay, 3 times 12 gives you 36. 3, I'm going to circle because that's a prime number. 3 is only divisible by 3 and 1. Okay, but factors of 12. Let's say 4 times 3. Ah, well, I see another number there, right? Another prime number, 3. I'm going to circle that one. But now 4 is not a prime number, so I've got to break it down even further. 4, let's say 2 times 2, and we're not using 1, of course, for any of these, because that would kind of defeat the purpose. It wouldn't break the number down. You'd still have a 4 down here. 2 is a prime number. It's the only even prime number. So I'm going to circle both of those. I can't go any farther. I can't break it down anymore. So the factors of 36, the prime factorization of 36, 2 times 2 times 3 times 3. Or, since we have 2 times 2 and 3 times 3, we could do 2 squared times 3 squared. All right. Let's do 36 again, but I just want to show you if you had chosen different numbers, then you still would have been okay. All right, so let's say with 36 for our factored tree, instead of starting with 3 and 12, we said, okay, well 2 times 18 is 36. Well, 2 is a prime number. I'm going to circle that. 18, I still have to break down a little bit farther. I know 9 times 2 is 18. Okay. 9 is not a prime number. I'm not going to circle it, but 2 is a prime number, so I'm going to circle that. And 9 I'm going to break down, and we know 3 times 3 is 9. 3 is a prime number, so I'm circling both of those. So again, 2 times 2 times 3 times 3. All the prime numbers in my factor tree. That is the prime factorization of 36. Factors shared by 2 or more whole numbers are called common factors. The largest of these is called the greatest common factor, or GCF is what I call it. Okay? Let's check out the factors of 16. When I'm writing factors in my little factor ladder or factor tree here, okay, I'm always going to start with the number 1, because I know 1 times the number is going to give you the number, obviously. 1 times 16 is 16. Then I'm going to move on to 2. I start with 1, I go to 2, I go to 3, I just go up until I'm done. 2. Does 2 go into 16? Well, it's an even number, so I know that it does. Okay, 2 times 8. What about 3? 3, 6, 9, 12, 15, 18. Nope, 3 doesn't work, so I'm not going to write it down. What about 4? Well, I know that 4 times 4 gives us 16. And I'm going to stop right there, because you'll remember, I said, when you run into a number twice, even if it's the same number, 4 times 4, you're done. So factors of 16 are 1, 2, 4, 8, and 16. Let's look at the factors of 24, shall we? Okay. You know, I'm going to start with 1 and 24. Kind of a sloppy 4, but that's okay. 1 and 24. 2, does 2 go into 24? Well, 24 is even. So 2 times 12. What about 3? Does 3 go into 24? It does. 3 and 8. What about 4? It sure does. 4 and 6. What about 5? Well, 24 doesn't end in a 0. It doesn't end in a 5, so it doesn't work. Okay. So what about 6? Well, 6 is already there, so I'm done. Easy thing to do the factors of 16 and to do the factors of 24. But now, if I asked you, what are the greatest common factor of 16 and 24? What is the GCF of 16 and 24? Now I'm going to look at this. They both have 1 in common. They both have 2 in common. They don't have 3 in common. They both have 4 in common. They both have 8 in common. And that's it. So they have 4 common factors, 1, 2, 4, and 8. Well, it says it right in the title there. What is the greatest of those? The greatest factor that they have in common is 8. So the greatest common factor, or the GCF, of 16 and 24 is 8. Okay, that's all I've got for you right now. I'll see you next time in class, and we'll be ready to do some work. All right, see you then.